Hello students, today we'll be seeing a new topic which is kinetics of particle, under which we'll be taking a D'Alembert principle. Now before starting with D'Alembert principle, we'll see first Newton's second law. So Newton's second law states that if the resultant force acting on the particle is not zero, the particle will have an acceleration proportional to the magnitude of resultant and in the direction of resultant force. What does this mean? That if the force is applied on a body, there will be a motion, and just because of the force there will be an acceleration which will be in the direction of the motion, and that is being mentioned here. Now F is equals to ma, where F represents the force acting on a particle, m represents mass of a particle, a is an acceleration. Now in this particular body, if multiple forces are acting on it at the same time, then when a particle is subjected to several forces simultaneously, then summation F is equals to ma. Now here, what is summation F? Summation F is just sum or resultant of all the forces acting on a particle. When this summation F will be considered? When a motion is happening, as we are talking about everything related to the motion. Now coming to next is your dynamic equilibrium. What do you mean by dynamic equilibrium? Equilibrium attains at the time of the motion. Now how it will be attained? If the motion is happening for a constant speed, then we can consider that there is a dynamic equilibrium. So motion with a constant or uniform speed such that net force applied or acting on a body is zero, and then you can say it as a dynamic equilibrium. Coming to next is your D'Alembert principle. Now when we see D'Alembert principle, rather than going with a statement, first we'll see the formula. So we'll see summation F minus ma equals to 0. What is happening? Here we have taken F is equals to ma, and here we are taking summation F minus ma. What does this mean? Simply ma is taken on a left side, taken negative, and then equals to 0. Only that much D'Alembert has done? No. D'Alembert had explained about the dynamic equilibrium. He says dynamic equilibrium. Now Newton's second law never mentioned about the dynamic equilibrium. They have only mentioned that if the force is applied, the acceleration is in the same direction of the force. D'Alembert says that the reaction due to inertia, what is an inertia here? ma, we can say ma, due to inertia of an accelerated body, a body if it is moving with an F force right side, then the acceleration will also happen right side, is equal and opposite to the force causing the acceleration. So this F is equivalent to this value and results in condition of dynamic equilibrium. When this value will be equals to this value, then the body will be moving with a constant speed and the net force acting on it is 0, and that's why here it is summation F minus ma equals to 0. So while writing the statement in the paper, see to it you are mentioning dynamic equilibrium. If not, you will not be getting the marks for the same. Minus ma represents the inertia force which is in the opposition to the force of direction of the acceleration. What is summation F of summation F? Accelerated force, the force which is causing the acceleration. Coming to next is your, what are the working rules or what is the procedure to solve the problem based on a D'Alembert principle? So for rectilinear motion problem, there is first part is draw FBD of each particle separately. Secondly, fix the coordinate axis system x and y axis and resolve as per coordinate axis. This we'll see in a example. Mark direction of acceleration known or assumed by dotted line. If you see here, the acceleration is being marked in a dotted form. Apply inertial force opposite to the direction of acceleration. The acceleration direction is right side and this is the inertial force which is acting on a left side. Apply condition of equilibrium. Summation f of x equals to 0. Summation f of y equals to 0. So condition of equilibrium says summation f of x equals to 0, summation f of y equals to 0. So that is under the same which is for a dynamic equilibrium as well. Now we'll see the second type of a motion, that Second type of motion here is for motion of a connected bodies. So if we'll talk about the motion of a connected bodies, the very first is mark the tension in the string connecting different bodies. Draw separately those bodies whose motions are interdependent and show only internal force. That is tension in the string acting on those bodies. Give small displacement known or assumed to each body and apply principle of virtual work / strings law. What is principle of virtual work? We'll see it in another video. Kinematic relationship between several motion. Draw FBD of each body. Mark direction of acceleration which is known or assumed by dotted lines. We have seen earlier. Apply inertia force opposite to the motion. Apply condition of dynamic equilibrium which is summation f of x and summation f of y equals to 0. Now, very important, in case where friction is involved, first find the exact direction of the motion and then apply D'Alembert principle. Now we'll see one problem based on which we'll apply all the rules whatever we have mentioned here. So the very first is to check 800 and 400. So here if it is mentioned the notation friction is involved, yes, friction is involved here. You have to be very careful with the direction of the motion. So if this is 800 kg, this is 400 kg, that means 400 kg will go above and 800 kg will come down. So for that what I'll do is I'll just mention the acceleration for this body is down and for this body the acceleration is above. Is it clear? Okay, let's start with the mark the tension in the string connected different bodies. So if I'm talking about the tension, this is the block. Away from the body there is a tension that is continued. For the pulley the tension is in this direction, that is same tension. As it is a common string, so here also there will be a tension which is T, and for this pulley it will be tension in away from the direction. The same pulley has the same string going above, so away from the pulley T and away from the support, that is also T. If these two T will be matched up, here you will be getting away from the block 2T and away from the pulley the same way. I hope you understood this tension. Now similarly we'll go with next is draw separately those bodies whose motions are interdependent and show internal force. You have to draw the FBD of this particular body as well as you have to draw the FBD of this particular body. Already you are knowing how to draw the FBD of the bodies. If you need a very specific, we'll go with the problem, in that you can check it. Next is give small displacement known or assumed to each body and apply principle of virtual work. Now in this case, if I'll talk about a principle of virtual work, so in this case I can give it as T into delta XA. This is moving for a small displacement delta XA, whereas this is moving, just because of this is moving down. So these two are opposite. So here we can consider that 2 times of T into delta XB. Can we write like that? If this is moving above, just because of this is moving down. So in that case, T delta XA whatever will go above will be same as 2T delta XB will be coming down. Hence we can write T into delta XA equals to 2T delta XB, which can also be written as T into delta XA minus 2T delta XB equals to 0. If we'll see this, it is force into displacement, which is equals to work, and this is something which is principle of virtual work. Still, if you need a principle of virtual work statement, you can go with another video which will be made by us. Okay, now kinematic relationship between the several motion. So kinematic relationship, basically we are applying all the kinematical equation when we'll draw the FBD for the separate bodies, which is summation f of x and summation f of y. Drawing the FBD of each body, we'll draw the FBD of each body that you already know. Mark the direction of acceleration, what we have already done here. Then apply inertial force opposite to the motion. In this, if I want to show, I'll show for one body. The body is moving down, it is having a weight downward direction, it is having an acceleration like this. So the MA will be acting here. At the same time, 2T will be also acting here, and this is your weight of block B. I hope you understood this. Now coming to next is apply condition of equilibrium, summation f of x and f of y. We'll apply here summation f of y and we'll write the equation for the same. I hope you understood this. Okay, one more important part what was mentioned here as in fix coordinate axis system and resolve it as per the coordinate. So that for this particular, the coordinate axis will be like this. This is taken x and this is taken y. But for this, we'll be fixing x is like this and y is like this. Please keep it in mind. Before starting with any of the body, you have to finalize the coordinate axis, and this is the part what we were talking in the previous working rule. I hope you understood this. Thank you so much.